Welcome back. Finally, we're going to finish this series by looking at the formula for a determinant of a 2 by 2 matrix. We recalled that we can write each coefficient in the 2 by 2 matrix using its row and column index, 1, 1, 2, 1. Here we start in the first row and second column, and then here the second row and second column. By definition, we said that the determinant of our matrix was going to be the sum over all permutations, in this case n is equal to 2, where we take the sign of the permutation and we multiply by the individual coefficients where the column index is given by the output of each permutation. Well, we saw that S2 had two permutations. We call them pi1, the identity permutation, and we have one transposition. In this case, we defined each of these using Cauchy two-line notation. 1 goes to 1, 2 goes to 2. And we can write that for now just because we're getting our heads around what this means. So 1 went to 1. The image of 2 is equal to 2 because that's the output right under that. And the same thing's true for pi 2. We start with 1. In this case, we said that 1 went to 2 and 2 went to 1. So we look at pi 1 of 1, and pi 2 of 1, and this was equal to the number 2. And then we said that pi 2 of 2, well, that had to go to the number 1. I'm not impressed with my writing on that, sorry. This should be the number 2. Okay. So the total number of permutations in S2, well, it looks like 1, 2. So we can look at this as the sum from j goes from 1 to 2 of the sign of pi j times a1 pi j of 1, a2 pi j of 2. Well, let's take a look at this. We're summing over two permutations. So the first one would be the sign of pi 1, a1 pi 1 of 1, a2 pi 1 of 2. So that takes the j equals 1 case, and now we sum that to the j equals 2 case, and we're going to have the sign of pi 2, a1 pi 2 of 1, because now we're looking at the j equal 2 case, and then we multiply that by a2 pi 2 of 2. Alright, so let's take a look. We knew from the last video that the sign of pi 1 was a positive 1 because there were no inversions there. So in particular, this would be positive 1 times a1, and then what we want to know is what is the image of 1 under pi 1. So let's see, 1 goes to 1, so this would be a1, 1. Here we want to know what is the image of 2 under pi 1. Well, 2 goes to 2, so that the column index must be 2. We also saw in the last video that the sign of pi 2 was negative 1. So here we add a negative 1 times a1, the image of 1 under 2. Well, let's see. Pi 2 takes 1 to 2, so this has got to be 2. And then we look at the image of 2 under pi 2. So here 2 goes to 1. Alright, so now we see that this is a11, a22 minus a12, a21. Well, this is the exact determinant formula that we know and love for 2 by 2 matrices. In particular, it's the product of the diagonal with a positive minus the product of this diagonal. And this positive came from the fact that the sign of the identity permutation is a positive, and this negative came from the fact that the sign of the transposition is a negative. Okay. In the next video, we're going to take a look at the determinant of a 3 by 3 matrix. I'll see you there.